Okay, so today we're going to talk about electronegativity. So basically, electronegativity is the ability to attract electrons. It describes unequal sharing of electrons between atoms, and it can help predict what type of bonding occurs. Okay, so I'm going to use hydrogen, but any atom attracts electrons. The electrons whiz around the atom, they don't just go flying off. The electrons are actually attracted to the atom. The force of this attraction is defined as electronegativity. The electronegativity values can range anywhere from 0 to 4, 0 being the weakest and 4 being the strongest. So let's say there was an electronegativity value of 0.5. That would mean that there's a very weak attraction. Weak attraction of the electrons. So moving on, you'll see in this periodic table, you can't actually see it, but it actually has the electronegativity values listed for each element. But as you go from left to right, the electronegativity values actually increase. Whereas if you go from top to bottom, the electronegativity values actually decrease. So here, you'll see francium. Francium has electronegativity value of 0.7. That's actually the lowest out of everything here. And fluorine actually has a electronegativity value of 3.98. That's the highest. The noble gases aren't actually, you wouldn't include them when you're talking about electronegativity. So moving on, I'll talk about this after, but let's say you have magnesium and oxygen, and you want to figure out what type of bond they will form. You'll want to look at their electronegativity first. So the electronegativity of oxygen is 3.44. You can refer back to this periodic table to find the electronegativity values for the element you want. But yeah, so magnesium has the electronegativity value of 1.31. Now you're gonna have to find the difference between the electronegativity values, and you'll do this by subtracting the highest electronegativity value with the lowest one. So here we're gonna subtract 3.44 with 1.31, which will give us 2.13. And now, remember this number. Now we're going to look back up to this chart, and we're going to see where 2.13 fits into. So 2.13 is in between 1.7 and 3.3. Therefore, there's mostly ionic bonding in magnesium and oxygen. So here you just want to put a little therefore statement. So therefore, magnesium oxide is an ionic molecule, and it has ionic bonding.